Now, I will show you another example of for graph tensile test. So, let us say that tar inflation pressure is equal to 650 kilopascal, and average stone diameter is equal to 50 millimeter. Now, geotextile is to be placed beneath the stone base course. So, assume %% of total ultimate graph strain will mobilize. So, we know that total ultimate graph strain. So, total ultimate graph strain is equal to 33%. I have shown you earlier. Now, what should be the mobilized graph strain? So, mobilized graph strain will be equal to 0.33 into 0.5 is equal to 0.165. So, you know the what is T required equation, that is A of P into dV square into epsilon. So, AP is equal turn inflation pressure is 650. So, this is 650 into dV is equal to your total ultimate graph strain value is 0.33. So, 0.33, that means this is 0.33 into 0.05 whole square, because the average stone diameter is 50 and mobilized graph strain is 33.33. So, this will be 0.33 into 0.05. This into the mobilized graph strain epsilon is 0.165. So, this will give you 29.2 Newton. So, this is the calculation for the graph tensile test. So, this is T required is equal to 29.2 Newton. So, here I have shown you some specimen calculation and theory based on the your brush strength and as well as for the graph strength. So, brush strength is very important for different types of the project where the geotextile or the material or the geomembrane material may burst. So, you should know what should be the brush strength required and what kind of geosynthetic material you should select for that specific application. As I told you, in case of the landfill, you should perform the proper types of the brush strength of the geomembrane or geotextile material. And secondly, that graph strength, it is just as an index test to quality control of this material, and because in the graph this entire portion of the clamp is not fixed with the geotextile material. So, this test is not so much reliable. Now, I will talk about some triaxial test of the geosynthetics material. Now, geosynthetic material should be placed in proper location. If we do not place in the proper location, you can observe, so what will happen? How the strength of the geosynthetic material can be improved by placing the geosynthetic material at a particular layer. So, you cannot place the geosynthetic material anywhere. So, location or placement of the geosynthetic material is more important. And also you will be knowing that what will be the strength of the material, how much it increase, what kind of improvement of the shear strength of the soil due to the introduction of the geosynthetic material. Now, let us perform some triaxial test. You know the triaxial test, and it is a cylindrical sample. It is a, let us say this is the triaxial. So, we will perform term triaxial test. So, these triaxial tests are to be confirmed, and there is a beneficial effect of geotextile when you place the geotextile material at the proper location. Now, you take some 2 or 3 tests on the dense sand sample and at a confining pressure. You can give confining pressure 21 kilopascal or 210 kilopascal for different soil and geotextile configuration. From this test, in both tests, let us say for a particular confining pressure of 21 kilopascal. So, you can represent the baseline shear strength data of the sand itself. So, you can draw the curve for the dense soil sample. Let us say that this is the unreinforced case when geotextile material is not there into the sample. So, you can draw a correlation between the axial strain in percentage, let us say 0, 5, 10, 15, and the deviated stress. Deviated stress, okay, that is in kilopascal. Let us say 50, 100, and let us say 150 kilopascal. So, when there is no reinforcement, no geosynthetic material in the sample, so you are performing some test. So, you can draw from the triaxial test at a particular confining pressure, you can draw the stress strain curve. So, let us say the stress strain curve for unreinforced soil, let us say something like this. So, this is one, let us say for unreinforced case sample. The sample where there is no geosynthetic material. So, this is only the sample. So, you know that in standard in conventional method how to perform the Triaxial test and can determine what will be the deviated stress and corresponding the strain value. Now, if you place a layer of geosynthetic material at the top and bottom of the sample, let us say you place in a Triaxial sample, you are placing a one layer of the geotextile material at the top and the bottom. So, this is geotextile material at the top of the sample and this is geotextile material at the bottom of the sample. So, you find even and if you can perform the test and if you can draw the curve, you find that it is almost the same. It is almost the same as in unreinforced soil sample. So, placement of the top and bottom on the soil does not show improve shear strength behavior. Since this location of the geotextile material are non-acting, dead zone, it is non-acting and dead zone in conventional Triaxial test. And this kind of the behavior is logical and instructive. It is instructive because it is teaching us that if the geotextile is placed at the wrong location, it will not any beneficial effect. So, that is why it is most important the placement of the geotextile material should be proper. Now, if I place the geosynthetic material in the central portion of the Triaxial sample. So, let us say now you place this geotextile material in the central portion of the sample. You can place also here, you can place also here 1/3, 2/3, okay. And you can perform the Triaxial test. And then you can draw the stress strain curve and you can find when you place the geotextile material for a particular confining pressure, then you find there is a improvement of the stress strain curve. So, let us test 2 when you have placed the geosynthetic material at the center. So, you can place also somewhere here, also you can place also somewhere here 1 layer, 2 layer, 3 layer, and you can find the stress strain curve is increasing with increasing the number of the placement of the geosynthetic material. So, it is very important the placement of the geotextile where you are place the geotextile material. It requires proper location of the placement of the geotextile material. Then it will be the beneficial effect of geosynthetic material. You can perform under different confining pressure. So, in general function of reinforcement in soil, and this also particularly applicable in case of reinforced soil retaining wall and also the reinforced soil slope. What there will be a good interaction between the soil and the geotextile material. So, this is one of the basic concept and mechanism that how the strength of the geosynthetic material is increasing due to the introduction of the geosynthetic material. So, proper location of the geotextile is most important. So, you cannot place anywhere of the geotextile material, as you see that when you have placed the geotextile on the top and bottom of the triaxial soil sample, there is no improvement. This acts as a dead zone or non-acting zone. Now, there are three different reinforcement mechanisms. One is the membrane type, another is the shear type, and another is the anchorage type. I will explain one by one. So, membrane reinforcement occurs when a vertical force is applied on the geotextile on the deformable subgrade. Now, depending upon the depth of the soil at which the geotextile is placed from the force applied, and then you can determine what should be the horizontal stress. You can determine what should be the horizontal stress at depth, let us say Z, an angle is an angle, let us say theta. So, you can determine the horizontal stress sigma h is equal to P divided by 2 into pi into z square, this into 3, this is sin square theta into cos q theta minus 1 minus 2 of mu into cos square theta divided by 1 plus cos of theta, where P is equal to applied vertical force, applied vertical force, and Z is the depth beneath surface where sigma h is being calculated. And mu is Poisson's ratio. And theta is angle from vertical beneath the surface load. The surface load, that is P. Now, if you put the load directly beneath the load where theta is equal to 0, if theta is equal to 0, then when the theta is equal to 0, because when you are placing the load directly when theta 0, then you can have the equation sigma h is equal to minus P by 2 of pi into z square, this half minus mu. So, if the mu value is less than 0.5, then what should be value of sigma h? Sigma h will be negative. That means which is tension. That is why the tension develops. That means applied vertical load produces that tension in the horizontal plane beneath it. So, as you place the geotextile material closer and closer, okay, for example, this is the triaxial soil sample. If we place the geotextile material in closer and closer, so what will be the load? Load will be the higher. Then higher the tensile stress value. That means higher the required tensile strength of the geotextile material. So, whether you are in putting on the very soft soil, there will be a yielding situation of this particular reinforcement mechanism. And if you can place the geotextile material in a distance in between, there is a spacing is defined between the two geotextile material, then you find the tensile strength is on the lower side. So, more the number of the reinforcement layer, and there is a more improvement of the tensile strength of the geotextile material. And this kind of application is mainly for the geosynthetics reinforced soil wall and geosynthetics reinforced soil slope, where you have to place the number of the layer of the geosynthetics in the construction of the reinforced soil wall. For example, if this is the facing element and you are facing the geosynthetic material, defined number of the layer like this. So, this is the geogrid material you are placing. So, this kind of mechanism applied in case of reinforced, mechanically stabilized reinforced soil wall. Also, this mechanism is applicable in case of the reinforced soil slope. For example, if you construct a steep slope, so you can place the number of the layer of the geogrid material. So, these are all this geogrid material. Okay. You have to place one layer in between the foundation and the embankment soil. So, this is the geogrid material. So, here geotextile material act as a tension, or geotextile material acts as a membrane type of the reinforcement. Now, geosynthetic material also act as a shear type. So far we mentioned about the reinforcement in membrane type. Now, we will discuss the shear type. Now, at shear we perform the test in a direct shear test. So, you can have a better visualization by the direct shear test. You know what is direct shear test, and you know how to perform the shear strength of the soil. Then we will perform how we can perform the shear strength of the geotextile material. So, a geotextile material is placed and on the direct shear test, and you have to perform the test. So, there will be the two material shear or shear in their interface. So, resulting geotextile to soil shear strength parameter can be determined. For an example that you wanted to perform some test, geotextile interface between the soil and geotextile material. You know that what is direct shear test. So, let us say this is the direct shear test in the lower part and this is the upper part. And this is, let us say, this upper part, let us say it is a wooden block, and lower part is filled up with the soil. So, this is the soil. Okay. And geotextile is paste with the wooden block. This is geotextile, fixed with the wooden block. Okay. So, if you can perform the direct shear test, we applied load and there should be a shear in between the soil and the geotextile material. And the resulting geotextile to soil shear strength parameter can be determined. So, shear strength parameter can be determined soil to geo, because this is a foreign body, and you can determine that from the traditional geotextile material using an adopted Moore Coulomb failure criteria. So, from the Moore Coulomb failure criteria, you know that tau is equal to C of A plus sigma of N into tan of delta. So, where tau is equal to shear strength, tau is equal to shear strength between the geotextile and soil, and sigma, let us say n dash is equal to effective normal stress on shear plane, effective normal stress on shear plane. Now, this Ca and this delta, Ca is the adhesion, Ca is equal to adhesion. So, this is, you can say, of the geotextile to the soil, and delta is the friction angle. This is friction angle between the geotextile and soil. So, shear strength parameter, that is Ca and delta, this can be compared with respect to the soil to soil geosynthesis material. So, from this you can determine what should be the adhesion, this is important, and what will be the friction angle. And from this also you can determine E of C, that means efficiency. efficiency of cohesion mobilized, and E of pi is efficiency of soil friction angle, soil friction angle mobilization, soil friction angle mobilization. You can also equally perform that soil to soil strength, and you can determine the what should be the C and the pi. See, you know that in case of soil to soil, you know the what is C, that is cohesion, and you know what is pi, and that called the angle of friction. So, knowing the value of the soil to soil cohesion and the friction angle, you can determine what should be the efficiency of the geosynthetic material in terms of EC and also E pi. So, these are the tensile strength. You can determine the basic mechanism of the triaxial test of geosynthetic material. So, from this test we can learn that what kind of geotextile material, where you should be located or it should be placed on the geosynthetic material. You cannot place the geosynthetic material anywhere. As you observe that when you are placing the geosynthetic on the top and the bottom, so there is no improvement. On the other hand, if we can place the geotextile material in the middle of the triaxial sample or 1/3 and the 2/3 of the geosynthetic sample, and you find there is a substantial improvement of the tensile strength of the geosynthetic material, because there is a mobilization of the friction between the soil and the geosynthetic material. Similarly, you have also shown that direct shear test, how it is the mobilization of friction between the soil and the geosynthetic material. So, any type of the material you can perform the direct shear test. It may be the concrete, it may be the geomembrane, it may be geogrid, it may be the woven and non-woven geotextile material. So, you can determine that what should be the efficiency in terms of the cohesion and what will be the efficiency in terms of the angle of the internal friction. So, this is very important, this parameter, to perform this kind of the test, that is triaxial test and as well as the direct shear test. Thank you.